Hello everyone, welcome to my channel Pragya's Gurukul. Suppose you have a piece of bread and your friend has a mini pouch of butter. Both of you are very hungry. Then what will you do? Obviously, you both will share whatever you have so that both of you can eat bread and butter, right? Similar is the case with some atoms. Such atoms like to share electrons to attain stability. As we know, there are two types of valencies, electrovalency and covalency. In our previous video, we have learned about electrovalency. Today, we will learn covalency and covalent bond. So, let's begin. What is covalency? It is the maximum number of electrons shared by an atom with another atom or atoms to satisfy octet rule or to attain a stable electronic configuration of its nearest noble gas. So, covalency is characterized by the sharing of electrons between two atoms. This sharing takes place in such a way that both the atoms attain 8 electrons in their valence shell. The only exceptions are hydrogen and helium, as they satisfy duplet rule. Now tell me why they do so. To achieve stability, isn't it? Let me give an example. Chlorine has atomic number 17. It has total 7 valence electrons. It will remain unstable until it attains one more electron to satisfy octet rule. So, chlorine atom can share one of its 7 valence electrons with other chlorine atom. This way, both the chlorine atoms have satisfied the octet rule. It is not the only possibility. Chlorine can also combine with hydrogen in a similar manner where duplet rule for hydrogen is also satisfied. Now, what will be the covalency of chlorine? Correct, it is 1. Remember one very important point. Unlike electrovalency, we do not need to write plus or minus sign with covalency. You know why? Because there is no loss or gain of electrons, only the electrons are being shared with each other. Moving on, atoms with covalency tend to share their electrons in two ways. Number 1, sharing of electrons between atoms of the same kind. For example, formation of H2, Cl2, O2, etc., where sharing of electrons take place within the similar types of atoms. Number 2, sharing of electrons between atoms of different kinds. For example, in the formation of methane, electron pairs are shared between two different types of atoms, carbon and hydrogen. Just like that, in water, electron pairing takes place in between oxygen and hydrogen. In ammonia, it takes place between nitrogen and hydrogen. Can you guess what holds these atoms together in a molecule? Definitely a chemical bond, isn't it? Such association of atoms through sharing of electron pairs is known as covalent bond. As mentioned earlier, no ions are formed during covalent bonding, unlike ionic bonding. The force of attraction that is present in covalent bonds is intermolecular force of attraction. Next comes types of covalent bonds. Depending upon the covalency, covalent bonds can be classified into 3 types. Number 1, single covalent bond where covalency is 1, double covalent bond where covalency is 2, and triple covalent bond where covalency is 3. Single bonds. It is formed when only one pair of electron is shared between two participating atoms. It is represented by 1 dash. Let's get started with methane. Its chemical formula is CH4. It means one atom of carbon combines with 4 atoms of hydrogen to make one molecule of methane. All the hydrogen atoms have only one electron in their outermost shell and carbon has 4. So, carbon shares one electron with each of the 4 atoms of hydrogen. This way, carbon has a complete octet and all the 4 hydrogen atoms have a complete duplet. This is how 4 single bonds are formed in the molecule of methane. Similarly, In hydrochloric acid molecule, HCl molecule, as discussed earlier, one electron pair is shared between hydrogen and chlorine atoms. By doing so, hydrogen has attained 2 electrons and chlorine has attained 8 electrons in the valence shell. In this case also, a single bond is formed between hydrogen and chlorine. Next comes double bonds. It is formed when two pairs of electrons are shared between the two participating atoms. It is represented by two dashes. For example, let's take oxygen molecule. Here, each oxygen atom has 6 electrons in their valence shell. So, how many more electrons do they need to complete their octet? Correct, 2. For that, the oxygen atoms share 2 electrons with each other, resulting a double bond between them. Similarly, carbon dioxide has 1 carbon and 2 oxygen atoms. Each oxygen atom has 6 valence electrons, whereas the carbon atom only has 4 valence electrons, right? To complete the octet, carbon shares 2 of its valence electrons with each oxygen atom. So, total how many double bonds will be formed in carbon dioxide? Yes, 2. Moving on to triple bond. It is formed when 3 pairs of electrons are shared. Such bonds are represented by 3 dashes. For example, in nitrogen molecule, each nitrogen has 5 valence electrons. Now tell me, what will happen if the nitrogen atoms share 3 electrons with each other? Correct. Both of them will satisfy the octet rule and this will result in the formation of a triple bond between the nitrogen atoms. Now, let's take ethyne molecule. It has total 2 carbon atoms and 2 hydrogen atoms. Here, each carbon needs 4 more electrons and each hydrogen needs 1 more electron. Each hydrogen can share only 1 electron with 1 carbon to get a full octet shell, outermost shell, isn't it? Now, how many electrons are left on each carbon? Good, 3 electrons. So, in the next step, the 2 carbon atoms will share 3 electrons with each other, forming a triple bond between them. Hope the concept of covalent bond is clear to you now. Make sure to comment and please subscribe to my channel and press the bell icon for further notification.